All right. So let's give it a second. If you could, on the live chat, go ahead and tell us if you can hear the audio now. I don't know what exactly happened there, but we should be good. So give us a yes, give us a thumbs up in the live chat, and we'll make sure that we're good to go before we get started.
Yep, it's working.
Okay.
Alrighty, so the metric system was developed by the French in the late 1700s. It's based on the powers of 10, which makes it very, very easy to use because you can convert from one unit to the other. So in the United States, we use the imperial system. We're literally one of very, very few countries that don't use the metric system. And we're very, very stubborn because we don't want to switch. But it would make it so much easier if we just use the metric system. It's used especially in science in order to record results. And it's abbreviated as SI, so that whenever I say the SI unit of something, that means the international system of the metric system that they typically use throughout the world. Now, some common prefixes that we have for the metric system is going to be kilo, centi, and milli. So we're going to use this quite often whenever we're talking about anything, any various topics in biology. So what you're going to notice is that the kilo is 1,000, centi is 1 over 100, milli is 1 over 1,000, so that all of them are interrelated in the powers of 10. So it's very, very easy to be able to convert from 1 meter to 100 centimeters, because 1 meter is equal to 100 centimeters. 1 meter is also equal to 1,000 milliliters. So again, very, very easy to be able to convert that, as opposed to thinking, okay, how many inches are in a foot, inches are in a mile, inches are in a league. So all that really is really difficult. This is a much simpler system. Now, this is the chart of the different units that we have. The good thing is, you won't have to memorize this. We will always give this to you for any type of assessment. So if you're wondering, okay, do we have to memorize this? No, that would be horrible. So we're not going to do that to you. Okay, so what you're going to notice is we have mega at the very top. Then we have kilo, hecto, deca, deci, and then we have our centi, our milli, and our micro, nano, and angstrom. What you're going to notice in the very middle are base units. Okay, so that's our unit of 1. And our base units are meter, liter, and gram. So from the very top, which is our largest, to the very bottom, which is our smallest, we can easily convert from one unit to the other. And we're going to explain how to do that. So the first type of measurement that we do is length. So length is the distance between 2 points, and we have our SI base unit being your meter. So we use rulers, we use meter sticks in order to find the length of an object. So we want to make sure that everybody understands how to do or how to measure length. Now, your first question that I want you to write down on your sheet of paper, the first answers I want you to put on your sheet of paper. What is the appropriate unit of length for the following? So the thickness of your fingernail, the distance between your house and HHS, the height of the roof of your house, and you're going to use kilometer, meter, or millimeter in these answers. Okay, so I'm going to let you guys take about a minute or two to think about that. Make sure to put those answers in the chat, and we want to make sure that you guys are understanding this. Yep.
right, we got an answer that came through, and I'm sure there will be more coming here in just a moment. So for A, the thickness of your fingernail, we had millimeter. For B, the distance between your house and Highlands High School, we have kilometer. And then for the height of the roof of your house, we have meter. So we'll give it another couple seconds. Here we go. Second one, millimeter for A, kilometer for B, meter for C. A is millimeter, B is kilometer, C is meter. So it looks like, at least from the first couple of answers that we have coming through there, we are spot on.
Alrighty, so again, good job, guys. Keep those responses coming. We love the participation. We love being able to hear from you guys. And hopefully you guys like the idea of participating in this live lecture. You're absolutely 100% right. Thickness of your fingernail is millimeter. Distance between your house and HHS is a kilometer. And the height of the roof of your house is a meter. So you can imagine that if you had the thickness of your fingernail measured in kilometers, that would not be a very accurate measure. That's why it's very, very important to make sure you have the appropriate unit of length. Okay, so we're going to do a live demonstration. We're going to show you a couple of different items, and we want to make sure that we understand how to read a ruler and making sure that with that ruler you're able to get as close of an answer as possible.
Okay, so I'm going to hop in here really quickly. I'm going to turn the camera around so that you can see the demonstration that Mr. Wen is doing. Bear with us. This camera is not perfect, so we'll try to zoom in as much as we can when we're doing these live demonstrations. We're going to have you do some estimates on length, so just do the best you can, looking at the tools that we have, and we'll go from there. Okay, so I'm going to turn you guys around. So here's our first item. All right. And again, I'm going to try my best to zoom in there. Oh, that's better.
So you are looking at the end of this iPhone. Okay, so where my finger is, that's where your measurement is as well.
So in that live chat, sorry, the camera's bouncing around. So in that live chat, go ahead and put what you think the measurement would be for the length of the iPhone case based on that ruler. Oh, there you go. Love it.
So that measurement right there would help you try to figure out what that length is.
Okay, what do you think that might be? All right, I'm going to put the camera down for just a second.
We've got 15 centimeters, we've got 15.75 centimeters, 15 centimeters, 15 centimeters, 15 centimeters. Everybody's using units, that's good. 15.5 centimeters.
All right.
Okay, so just making sure that we're very, very clear about this and make sure that we're able to read a ruler. So each one of those large marks is a centimeter. Okay, so if we're starting towards the end, that's 1, 2, 3, 4, 5. So the large numbers are centimeters, and then the small tick marks are going to be your millimeters, and there's going to be 10 in between each one of those. So when we're looking at the iPhone, anywhere from the 15.5 to 15.8 would be fairly accurate in terms of an answer. So good job on that. The reason why it's a little bit harder to measure the length of that is because of that plastic case. So it makes it very, very difficult to see where it ends. All right, we're going to do the next one, which is going to be the diameter of the tape.
So here's our tape. Mr. Wen is holding his ruler again. I'm going to try to zoom in here so you can see. Again, remember that your big numbers up there 9, 10, 11, 12, those are your centimeters, and then the smaller marks in between, those are your millimeter marks. So again, what would be your best estimate for what you think that may be? Okay. Throw that in the live chat. Again, bear with us. It would be way easier in real life to use your own eyes and actually look at the ruler with your own eyes, but we're doing the best that we can with the situation that we're in. So,
now for consistency's sake as well, make sure that your answers are in decimal form. Okay, so while we love fractions, and fractions are equally important in other classes, in science we generally use decimals in order to represent numbers.
all right, so it looks like we have a lot of answers that are coming flying in. Thank you for your participation. I mean, they're coming in fast. It looks like, I'll start back up at the beginning, we got a whole bunch of 11 centimeters, and you have your units there. Awesome. 11 centimeters, 11 centimeters. I saw an 11.1 centimeter. So mostly 11 centimeters. We do also have an 11.1 centimeter. So
Okay, so yeah, absolutely 100% right. The 11.1 to 11 centimeters, that range is really, really close in terms of the accurate answer. So good job on that. I would probably put it at 11.1, but again, that 11 is really, really good.
all right, great job, guys. We'll turn you back around.
Okay, so what we did is essentially what these two words represent, precision and accuracy. So we were trying to get the exactness of a measurement, and not only that, but we're also trying to get the closest correct value. And so depending on how accurate or how precise you need to be is going to be dependent on your instrument. So I'm going to explain the difference between precision and accuracy using an example. So Highlands is in Fort Thomas. That's accurate, but it's not very exact. If you told somebody, okay, I need you to meet me at Highlands High School in Fort Thomas, and then you just hung up on them, okay, they would be wandering all over the place wondering where Highlands High School is. Now, in terms of precise but not accurate, Highlands is at 15 North Fort Thomas Avenue. We could go to 15 North Fort Thomas Avenue, take a picture of it and go, hey, you know what? We're not in front of Highlands High School. Because while it's precise, it's not very accurate. Highlands is at 2400 Memorial Parkway, Fort Thomas, Kentucky. That is an awesome answer. Precise, accurate, that's what we want in science. We want both. Okay? So making sure that we're very clear about our answers and making sure that we're also precise with our answers as well. Now, the next physical characteristic we're going to look at is mass. So mass is the amount of matter that an object has. And generally speaking, we have, let's say, for instance, two things that are of relatively the same size, a golf ball and a ping pong. So we know that the golf ball has more mass because it has more matter in it. So in that instance, even when looking at the size, we have to make sure to calculate its mass. Now, the base unit for mass, the SI base unit for mass is the gram. So, to get an idea of what a gram is, it's about the size of a paperclip. And the mass of an object will not change unless we add or subtract matter from it. What that means is that if we were to crush it, if we were to cut it, if we were to alter the object in some way, shape, or form, then we've changed its mass. But, let's say, for instance, we take it to space, you haven't changed its mass. You've only changed its weight. Okay, so I'm sure some flashbacks from physics that you guys are imagining, but there is a difference between mass and weight. Now, how do we measure mass? So we use a triple beam balance. And we're going to talk about how to use a triple beam balance in making sure that everybody understands how to read the numbers and how to make sure that you get your accurate mass. So, another question I want you to add to your paper. Okay, so what would be the appropriate unit of mass for measuring the following? Kilogram, gram, milligram, the amount of vitamin A in an energy bar. Mass of a bowling ball, mass of a mouse. Alrighty guys, so once you have the answers down on your paper, make sure to add that to chat and we'll make sure that we go over it and see whether or not we're on the right track. Thanks guys. Good.
All right. Hopefully we'll have some answers coming in here pretty quickly. All right, so we have the first two that came in. We actually have some varying answers, so we'll make sure that we take a minute to talk a little bit about that. So here's what we have. So the first one that came in, the amount of vitamin A in an energy bar, we had gram, the mass of a bowling ball, kilogram, and the mass of a mouse, milligram. And then we have some other ones coming in here. Actually, that was just deleted. I think whoever put that in there maybe decided that they wanted to change it.
That's okay. That's good.
That's fine. That means that you're paying attention and you're looking at that live chat. So we have the amount of vitamin A, milligram, the mass of the bowling ball, kilogram, and the mass of a mouse, a mouse. The mass of a mouse is a gram. And I would say, for the most part, we have agreement in A being milligram, B being kilogram, and C being gram.
Alrighty, good job guys in terms of using your appropriate unit of mass. I can imagine using a milligram for a bowling ball won't do much. It won't do much anyways for my bowling score, but it is a really, really relatively small size. Alright now, so calculating the mass for each triple beam balance, we want to make sure that we know how to read a triple beam balance. So our first line here is our ones place. Our second is our hundreds place, and our last is our tens place. So you want to make sure that you keep in mind which one you're utilizing when making sure you're measuring the mass of any item. Okay? So we'll talk about which one you should use first, but what I would like you to do in your chat is to record what this mass is representing on this triple beam balance. So go ahead and do that now.
So again, using that image up there on the overhead, let's see if we can't, in the live chat, let us know what you think the reading is for mass based on the triple beam balance picture up on the overhead, and then we'll actually do a live demonstration and show you what this looks like. So what do you think? Oh, here we go. We got some coming in. So we actually had 37.25 were our first two, and then we have some coming in that are 37.3, 37.3. We got another 37.25, 37.3. We had a 37.35. So we have right around that 37.2, 37.3, 37.4 grams for the measurement from the triple beam balance.
Yeah, and good job, guys. So right here, 37. So the 37, and that's a 0.3. So that might be the reason why we're getting a little bit in terms of the 0.25, 0.35. If you're not 100% sure that that's on the 0.3, but 100%, that would be 37.3. Good job, guys, in terms of being able to read the triple beam balance. Now, the live demonstration, we're going to have two objects. So you want to make sure to add this to your paper as well. So we have an iPhone and we have a masking tape, and all we're going to do is measure the mass.
All right, I'm going to turn you guys back around a little bit, try to do a better job of not being so shaky. Okay, so here's our triple beam ballast, just like you saw in the picture. All right, we have our stage over here where we're going to put our object. We have our weights here in the middle. They look just like they did, and I'll let Mr. Wen talk a little bit about that. And then we have this neat little thing over here that's actually going to help us determine what's going on with the mass. Okay, so I'll let Mr. Wen take it over, and he's going to talk you through this.
Okay, so the first thing is you want to make sure you reset all of these different weights. So notice all of them are to the left. So they're all on 0. Now I'm going to go ahead and put my phone down. Okay. And I'm just gonna go at it. I'm just gonna go at it.
Ooh.
Right? I got it, didn't I?
I would say that's probably not the best way to go about it. Do you think that there could be a better way to do that?
Well, I think so. Okay, let's reset and let's try it again. Okay, so I think we go with the highest amount first.
Okay.
Okay, so let's do the hundreds. Okay, now notice that whenever I slide it, that it's got a lock in place. Okay, so we're gonna lock that. I'm gonna lock that. Oh, it went down. Okay, so that means that this object weighs more than 300 grams. So I got to back it up. Okay, then I'm going to go to tens place next. Okay, we're going to go up, we're going to go up, we're going to go up. Oh, it's starting to move. Okay. Okay, notice it has to click before you make that decision. All right, so then that went down, so now I'm going to back it up a little bit. And then, ooh, it's close.
So if we look over here,
it's close. So we're going to just move this slightly over.
pretty good. Okay, so as you can see, Mr. Wen moved the hundreds place first, okay, and that's our value for the 100. He moved the 10 place, and that's what he landed on for the 10. And then he slowly moved our ones place up here, and he landed on that. And I know it's just a little bit difficult to see, okay? And the way that he knows that the mass is spot on is he looks over here at this. See how the lines are lining up together? Okay? So for the mass of the iPhone, in the live chat, see if you can put what you think it is. Here's your 100. Here's your 10. And then your ones place is right down there. I know it's not perfect, but see what you think. Okay. Okay, so see if you can throw that into the live chat. What do you think it might be?
We're seeing 250.2 grams. Another 250.2. Remember to put your units in. Got a 250.1 gram. $250.2, 250.1. Everybody's using their units. That's awesome.
Love it.
Alrighty, so good job, guys. You're absolutely 100% right. It is 250.1 or 0.2. So it's right in between those two numbers. And if you had put in one of those answers, I would give you credit. I mean, that's really, really accurate. So good job on that. All right, we're going to try the next item, okay, which is going to be the tape. Okay, so just as before, we want to make sure that you zero this out, okay? So, zeroed out, we're going to start with the hundreds. Okay, then we're going to start with the tens. Okay, and that's gone down. So, now we need to back that up to 0. Okay, and now we need to move just slightly the ones place again.
It's a little low. Go back just a little bit. It's pretty close. Yeah. Okay. So Mr. Wen started with the hundreds. Okay, so he landed here with the hundreds. And then he went to the tens, and he landed there with the tens. And then he came up to our ones to finish off the process, and he landed here with the ones. All right, so we have our tape. We have our hundreds right here, our tens in the back, and our ones up here in the front. So in the live chat, what do you guys think would be a good estimate for the mass of the tape based on what Mr. Wen did there with the triple beam balance? Okay, put that into the live chat.
Seeing 100.1 grams,
Nice.
100.2 grams,
Oh, they were-
100.1 gram,
They were on it.
100.1 grams. Yep.
Okay, beautiful, guys. You guys were on it that time.
And they are using their units.
Love it. Love it. So as Mr. Wen said before, this one also kind of fell, and I know it's a little bit difficult to see, but it kind of fell in between that 0.1 and 0.2. So anything 100.1 or 100.2 would definitely be a good answer for the mass of that tape. So awesome job. I'm going to turn you guys back around. Bear with me. Back up here. All right.
All right, and the last physical characteristic that we're going to talk about is volume. So volume is the amount of space an object takes up. So we could have something that's a regular object, like a box. So if it has a box shape, very, very easy to be able to calculate the volume. You look at the length, you look at the width, you look at the height, you multiply all that together, and you get the volume. However, that's not always going to be the case with irregular shapes and other shapes that don't follow this box shape, so like a circle or a sphere. So there's definitely different equations that you can apply to volume, so you want to make sure that you're utilizing the correct equation. In this case, the units would be cubic centimeters, because if each one of these were centimeters on the sides, and you multiplied centimeter times centimeter times centimeter, you get centimeters cubed. Centimeters cubed is also an SI unit as well. Okay? Generally speaking, though, we like to use liters. So the base unit for volume is a liter. We're going to use a graduated cylinder in order to measure the volume of our liquid. And we want to make sure that we understand what we're looking for, because a lot of the times it can be very, very difficult to figure out where that liquid sits in the graduated cylinder. What you're looking for is the lowest point of a graduated cylinder, which is called the meniscus. Okay? So the meniscus occurs because of adhesive forces where that water is being attached to the side of that tube, and it causes the dipping to occur. So we want to read at the very bottom of that particular liquid. So that's what I want you to do. So looking at this graduated cylinder, we're looking at milliliters. how many milliliters is in this graduated cylinder. So we have this graduated cylinder here and a close-up view of that section to make sure that we're able to see the meniscus. So in the chat, go ahead and put in how many milliliters you believe this graduated cylinder has.
So in that live chat, go ahead and put what you think the measurement is here in milliliters for the liquid that we have in the graduated cylinder up in the picture. What do you guys think? We got some that are starting to come in. Awesome.
All right, I'm seeing 43 mils. I'm seeing a couple 40 point something. So each tick is actually 1 on this graduated cylinder. So look again. Awesome.
Awesome,
Okay.
awesome.
So you guys might be wondering, well, how do you know how much a tick is worth? Well, we're going to have to look at 2 numbers. So we're going to look at this number here and this number here. So the increment of that corresponding unit, and we're going to subtract the 2. Now you can do it for any one of these in order to figure out what those ticks represent. But if we take 50 minus 40, that'll give us a difference of 10. There are 10 ticks, so that you can do 10 divided by 10, and each one of them is worth 1 milliliter. Okay? So it's really, really important to make sure that you know what your unit of measure is.
Great job, guys.
All right, question number 5. So let's add this to your notes. So what would be the volume of the following graduated cylinders? Graduated cylinder number 1, number 2, and number 3. We're going to do a live demonstration here in just a second, but making sure that you're looking at the bottom of the meniscus. So that can be very difficult to see, guys. But I'm going to try to move you around. This is going to be like GoPro Bio. So that GoPro Bio is just action shooting so that you guys have an opportunity to see what that volume is. Okay. So this is going to be graduated cylinder number 1. This is going to be graduated cylinder number 2. Okay. So number 1, number 2.
So guys, we know that it's not perfect. Mr. Wen is trying to move it around to get the camera to focus. Imagine that you're seeing this with your own eyes. It's obviously going to be much easier in that kind of situation. But do the best you can. So look at those big numbers on the graduated cylinder, all right? And then figure out how much, what the difference is between the big numbers, and then try your best to see how many tick marks there are in there so that you can estimate what that volume in milliliters will be in the graduated cylinder. So go ahead in that live chat if you want to throw out there, what do you think graduated cylinder 1, what do you think that measurement is, and what do you think that measurement is for graduated cylinder 2? Do the best you can. Make your estimate in there. And then we'll move on to graduated cylinder number 3 after we do that.
Now, what's interesting to note is to make sure that your number is between 6 and 7 for the first graduated cylinder, because it cannot be above 7, and your answer cannot be below 6. Same way with the graduated cylinder on the right. Your answer cannot be above 20, and it cannot be below 15. So, making sure that we're utilizing our context clues for what the answer could be.
Alright, so we've got some answers of 6.7 mils for number 1, 6.6 mils for number 1, 6.7 for number 1. We've got 18 mils for number 2, 18 mils, 18.5 mils for graduated cylinder number 2.
Okay, guys, so good job on that. So the answer for graduated cylinder number 1 is going to be 6.6 milliliters. The answer for graduated cylinder number 2 is going to be 18 milliliters. Okay, so good job on that, guys. Now, your next one is going to be the graduated cylinder that holds 100 milliliters.
So as we did with the first two, the very first thing we want to notice is that the liquid is falling between 50 and 40. So we want to see how many tick marks we have in between those two numbers and what each tick mark is worth. As Mr. Wen said before, that value cannot be larger than 50 or smaller than 40. So it's going to fall somewhere in between that 40 to 50 range. So in the live chat, go ahead and throw out there, what do you think the estimate would be for that last, oh, that's a good. So again, it's a little bit difficult, but Mr. Wen's doing it. Maybe he has a second career as a graduated cylinder cameraman. Pretty awesome work there, buddy.
GoPro Bio.
Right?
That's
Pretty
my
good.
that's my new company.
Alright, we're seeing answers of 46 mils, 47 mils, 46.5 mils. Wow, this group is good about using units.
Alrighty, guys. So the correct answer is 46 and a half. If you had 46, if you had 47, good job. The reason why it is not 47 is because it's just a little bit underneath 47, but I think I would accept that answer. It's fairly close. And it's interesting because it has evaporated since the last period.
Great job, guys. Wonderful, wonderful, wonderful job. Keep up the good work, guys. You are rock stars.
All right, so fun fact, in terms of the metric system, 1 ml is also equal to 1 cubic centimeter. So that's the reason why the cubic centimeter is considered an SI unit. Very, very easy to be able to convert between the two. So what we talked about so far is your meter, which is your length, your gram, which is your mass, your liter, which is your volume. But there's a couple things that are still basic metric units that you want to know, but we are not going to show in terms of a demonstration. It's going to be Celsius and Kelvin for temperature and seconds for time. Okay? So the Celsius and the Kelvin, what you're going to see in most biology literature is going to be the Celsius, whereas with the Kelvin, that's generally going to be physics and physics literature. So in the United States, of course, we use Fahrenheit because we have to be difficult. So the 32 degree Fahrenheit is water freezing, whereas the 212 Fahrenheit is where water boils. Why we pick those two numbers, I have no idea. Okay? But in terms of what Celsius would look like if we were to actually use it, 30 would be hot, 20 would be nice, 10 is chilly, and 0 is ice. Seems pretty easy to me, but we apparently like the Fahrenheit system. Now, the last part of this presentation deals with conversions. So way back at the very beginning, I told you about these conversions. I told you that they were base 10s, so it makes it super duper easy to be able to convert from one to another. So we want to make sure that we're able to do that. So we're going to have your kilo, hecto, deca, your base unit, deci, centi, and milli as our scale. So you're going to use that in order to help you to be able to convert all these different types of numbers. So if you're going to the left, if you're going from, let's say for instance, centi to kilo, you're going to move to the left. If you're going from kilo to centi, you're going to move to the right. And what you're going to notice is that when you're moving to a smaller unit, that number is going to get bigger. Whenever you're moving to the left, that number is going to get much smaller. So we're going to try the first one together. Okay? So 422 centimeters. And if you can't see that, I apologize. We'll make sure that we call out these numbers so that you'll have an opportunity. And also remember that you're going to have access to this PowerPoint as well. So 422 centimeters is equal to how many meters? Okay, so take about a minute, try to see whether or not you can convert that, and then we'll discuss what the answer is.
So if you could, and I know some of you might be more confident with this than others, if you could put that into the live chat there. So if we have 422 centimeters, how many meters would we have? So using that, the kind of timeline looking thing up there with the units, and then up at the very top we have the arrows, and it tells you a little bit about what to do with the decimal point when you go from left to right or right to left. So see if in the live chat you can't put out there, what do you think in meters it would be if you had 422 centimeters?
All right, so I'm going to go ahead and start working on this while you guys are doing it. Okay, that way Mr. Ewald and I can show you exactly how to do it for those individuals that are just waiting. So 422 centimeters is equal to how many meters? Okay, I'm going to find my centimeters first. Okay, so I found my centimeters, and I need to change it to M. Okay, so there's M. So I'm going to go from C to M.
Well, hold on. You kind of jumped the gun there a little bit.
Well, that's M.
It is an M. That is the truth. But we have to think back to the very beginning when we learned what these prefixes were. The C is in fact centi, in this case centimeter. But the unit that is smaller than a centimeter, it's not actually going to be the meter, it's going to be the millimeter.
Oh, you're right, Mr.
Just helping you out, buddy.
Okay, so I need to find another M. Okay, so let's find another M. Okay, there's the other M there. Okay, so that must be the meter. So in this case, if we're going from centi to meter, well, how many times do I move? 1, 2. So I'm going to move 2 times. And what direction did I move? I moved to the left. So I'm going to move 2 times to the left. 1, 2. And my answer is going to be 4.22 meters. If you have that answer, good job. If you don't, that's okay. We're going to practice and make sure that we understand how to do this. Okay, so for the other one, so this is 69.63 liters, 9.23 grams, 6,523 millimeters, 13 deciliters, 230 milligrams. Okay, so I'm going to give you guys about 3 to 5 minutes to kind of work out the rest of these and see whether or not we can come up with the answers. We're going to do one more together to make sure that we understand, but we're going to give you some time to make sure that you're able to convert.
And don't worry about putting those into the live chat, guys. You can put them in there if you want to, if you feel like that's something you want to do. But if not, make sure that you're recording these in your own notes, so whether in your notebook, in your binder, in your computer, wherever that might be.
Alrighty, so we're going to do this next one here. And if you haven't finished yet, that's okay. Again, this is just to make sure that if there's anybody out there going, you know what, I have no idea how to do this, please just do them all for me. We're going to do this one and making sure that we'll get you to the right path. Okay, so 69.63 liters. So we're going to go and we're going to find liters here. And we're trying to convert it to milliliters. So milliliters is over here. So in this case, we're going to go to the right. And we're going to move 3 times to the right. So 1, 2, 3. 3 times to the right. So that our answer, if we move our decimal 3 times to the right, 1, 2, 3, add a 0, is going to be 69,630 milliliters.
So again, just make sure on your end that you're taking a couple of minutes to see if you can't convert those values. Don't worry about putting them in the chat. Don't worry about doing anything like that. Just make sure that you're practicing on your end.
All right, now the last thing is going to be whether or not you have a unit that isn't a factor of 10. Well, what do you do? So Vinny emptied his piggy bank. He had 22 quarters, 7 dimes, 9 nickels, and 75 pennies. So he had a bunch of money. That's a lot of money there. How much money does he have in dollars? So he wants to go and he wants to convert all of this money into dollars. Well, how would you do that? Well, you have to first consider how many quarters are in a dollar, how many dimes are in a dollar, how many nickels are in a dollar, and how many pennies are in a dollar. And I'm going to show you that conversion here in just a second. So here are our coins. So 22 quarters, 7 dimes, 9 nickels, 75 pennies. We know that $1 is also equal to 4 quarters. Now, you always want to put the unit that you're trying to get rid of at the bottom, the denominator. So we're trying to get rid of quarters. So by doing that, we leave ourselves with just dollar as our unit. So in this case, if we were to multiply across 22 times 1 and then 4 times nothing else, our answer would be 22 over 4, which is $5.50. We're going to do that for every single one of the different coins. So that if we were to add all of these numbers up, the $5.50, the $0.7, the $0.45, and the $0.75, it would give us a total of how much Vinny had in his piggy bank. That's like $1 million. Or $7.40.
But if Vinny were 4, like my daughter,
That's
that might as well be $1 million. So $7.40 for my 4-year-old. That's some serious money.
Alrighty, guys, that is it for us. Thank you guys so much for participating. Thank you so much for being part of this live lecture. We are having a blast hearing you guys and being able to participate with you guys virtually. The only thing better would be is if you guys were here. So, any other questions? Make sure that you send us an email, Microsoft Teams chat, whatever that we can do to make sure that we can help you. Make sure to turn in the questions by the end of your class period. So you're going to check Schoology to make sure you have instructions on how to submit it. You're going to check Schoology to see whether or not your teacher has assigned any work. I know that I have assigned work, Mr. Ewald has assigned work, and Ms. Becker has assigned work for the metric system. So it's a metric system worksheet, and you want to make sure that you check Schoology for that. Mine will not be due until Thursday, so you have plenty of time to be able to get it done. Mr. Ewald? Same Thursday?
Same.
And Ms. Becker, same as well. Okay, now, your next time-bound event will be small groups or individually. We're going to give you some more information about that and making sure that we convey what our next activity is going to be. Okay, so thank you guys so much. And if Mr. Ewald and Ms. Becker has anything else to say,
Good
I
deal.
appreciate you guys.
Yes. Great job, guys. Thank you
Thanks,
again
guys.
for participating and doing your thing. We love it. Have a great day. We'll see you during our teams meetings over the next couple of days.